Hello everybody and welcome to this CMEMS presentation and demonstration. I'm Etienne Seik from Noveltis and today I'm going to introduce you to a new QGIS plugin developed by Noveltis for the Copernicus Marine service and which enables an easy NetCDF files manipulation. NetCDF is a command file format used for meteo and oceanic data which handle several variables. All data available for free on the Copernicus Marine Service are distributed at the NetCDF format. In this first part, I will show you how to download and install the NetCDF plugin and how to use it basically. The zip file used to install the plugin is available following the link in the description of this video, and the user manual is also available. Once you have opened your QGIS software, you can go to plugin, manage and install plugin here, and you can go to install from zip to install plugin from the zip file downloaded on the CMEMS website. You can browse on your directories and select the netcdf to QGIS.zip and click on open. Here you can click on install plugin. The plugin already installed on my QGIS, and close this window. I need to inform you that you have to install QGIS with the OSGeo4Wind method as described in the user manual to avoid any problems of Python environment in QGIS with this plugin. Once it is done, you can see that the icon of the Copernicus Marine Service is here, and you can click on it to open the plugin. Here you have two separate panels. On the left side you have the NetCDF and the QGIS layer panel, and on the right side you have a panel corresponding to variables, metadata of the NetCDF files, and some options. First of all, we are going to set this path on the option panel. First of all, you can add an input default directory. So to load your CMEMS or NetCDF data, you can select the directory containing your data and click on select, and on the save default directory you can select the default directory to save the new layer you are going to create with this plugin. So you can select another directory. Now we are going to open some NetCDF. First of all, you can click on the plus icon here to import a NetCDF, but you are limited to import NetCDF one by one. Or you can just drag and drop your NetCDF from your directory to the plugin. Now you can see that your first NetCDF is here, so you have the complete name here and the path of this NetCDF. You have access to all the variables contained in your NetCDF, and here also you have access to several metadata with the resolution of the project and plenty of information regarding your project. Here it's a model project extracted from a physical model at a monthly temporal resolution, and we are going to display some variables of this project. If we select the salinity variable here, you have two options to display this variable to your QGIS project. So first of all, I can right click on it and select add layers, and here the one option of this plugin is to select directly a time frame of your NetCDF file, avoiding the complicated properties of QGIS. So here we can select directly one or several time frames, selecting with control. I select the first 3 time frames. I have only one depth, so I don't need to select a depth. and I can change the name of the group to import the layers on. Here I set the minimum and maximum value on the minimum and maximum value of all layers, and I keep this palette. You can click on add and close here, and you can see that on the background the 3 layers have been imported to your QGIS project. If you zoom on your map, then you can see that you have your several layers here. You can go back to the plugin, and here I am going to show you how to visualize several time frames in a kind of animation. So you can right click on your variable you want to display and select sequence layers. Here typically you can select all the time frames or several time frames using Control or using the Shift key on your keyboard and going to the bottom of the time frames. You can select all the time frames, select the name of the group and the minimum and maximum value of the layers, and select a time step to display each frame. Here we select a frequency of 2 seconds and we can click on start. If we go to our QGIS project on the background, you clearly see that there is an animation running, and each 2 seconds you can see the layer changing from a time frame to another. So it's really convenient to see quickly the evolution of one variable in QGIS using this NetCDF plugin. Then you can go back to the dialog box and stop the animation. Now you can close this window and go back to the plugin. Other option you have are to check or uncheck some layers on your QGIS project, or to remove some layers from your QGIS project. Here, if we activate all the layers, you can go back to your QGIS project, and for example, if you want to remove the layer corresponding to the 16th of October 2020, here you can right click on it and remove it from list. Yes, and you will see that it will remove this layer. Now you can also uncheck some layers. For example, if I want to uncheck the first layer here of the sequence group, I can go to the sequence group, find the layer and right click on it and select uncheck in QGIS. And now you can see that this layer has been unchecked. So you can play with several layers like that and remove some layers, or you can also remove all the group. So if you select one layer in the group sequence and click on remove group, and yes, all the sequence group has been removed. So here are the basic options of this plugin. One last option is to save one layer as a TIFF. So if we go to the layer, select it, right click on it and select save as TIFF. Here you can select a directory, or if you have changed the output directory here in option at the beginning, it will be displayed here, and you can select the palette you want to use to extract this layer as TIFF. And now you just have to select save as TIFF, and your new layer as a TIFF format is saved and displayed on the QGIS project. Thank you for your attention. There is a part 2 of this demonstration providing you some additional and more complex option of the QGIS. Hello and welcome back to this CMEMS presentation of the new NetCDF to QGIS plugin developed by Noveltis for the Copernicus Marine Service. In this second part, we are going to see more advanced functionalities of the QGIS plugin. Here we are going back to the NetCDF tab here, and we are going to import two model and observation products which don't have the same resolution. So we are going to select an observation product of sea surface temperature here, and also a model product of sea surface temperature on the month of April, the 15th of April here. Click on open. Now we are going to add the first layer corresponding to the analyzed SST variable. So we don't have to select any time frame because this file is containing only one time frame. Click on add and close, and go back to the NetCDF file list, and you can select the global model products, select the sea surface temperature variable, and add it to your QGIS project. Selecting add and close again. If we go to our QGIS project here, we can see that I'm going to hide the previous layers. Here we can see that the observation sea surface temperature and the modeled sea surface temperature don't have the same geographical extent. And if we go to the NetCDF to QGIS plugin, we can see on the metadata that the observation has a 0.05 resolution, and the model SST has a resolution of 1/12 degree. So if you have variables and products that don't have the same resolution and the same geographical extent, there is an option in this new plugin to align your rasters in order to have grids which are corresponding. So if you select your two SST layers we just loaded, here you can right click, select the two layers using the control key on your keyboard, and you can right click on the layers and select align raster. Here we can select the reference layer to align the second layer too. So we are going to align the two layers on the model product here, which have the coarser resolution. Once it is done, you can select here your output directory. Once it is done, you can select the align option here. And here you have a new layer corresponding to the observation layer here, but aligned on the model product grid. If we go to the QGIS project and we compare the observation product aligned and not aligned, you can see that there are some modification at the coast. And if we zoom to the layer, we can see that the resolution at the layer is not the same, because this observation layer had been modified and in order to correspond to the observation and to the model layer. Here we have the model layer with the coarser resolution, and here we have the new aligned analyzed SST layer corresponding to the model layer. So this is a good option to make your two layer corresponding before applying some modifications and some operations with a raster calculator tool. If you want to make a difference or other operations between two layers. A second advanced option of this plugin is the option to display vector fields. To do so, we are going to import a new file, a new netcdf file containing eastward and northward seawater velocity. Here is the new netcdf file containing the two variables at a 112 degrees resolution from a global model with a monthly mean temporal resolution. Before drawing this vector field, we are going to hide the two layers we have aligned before. So you can select the three last layers and click on Uncheck in QGIS to hide these layers. Here, if we go back to the netcdf file containing U0 and V0, we are going to import and add each layer to the QGIS project. So we are going to select the layers on the month of October. Click on Add and Close. You can do the same for V0. Add layer, October, and click on Add and Close. And here on the background you can see that you have your two layers imported. If we go back to the plugin, we are going to the Layers tab, and here we are going to draw a vector field of these two components, eastward and northward seawater velocity components, to have a vector field and not scalar fields corresponding to one to the U0 variable and one to the V0 variable. So you select your two layers by pressing the Control key on your keyboard, right click on the two layers and select Vectorize. Here you have several options. You can select the UV components because we are using a component for the eastward velocity and a component for the northward velocity. Load the layers corresponding to your components, and here we can change the norm because the norm is not the same for currents and for wind and waves, so we are selecting currents. We are going to apply a downsampling, which is a ratio selecting, for example, if I select a downsampling of 10, it's going to display one vector out of 10 on my grid. So I select the downsampling of 10. I can change the output directory, but by default it's the output directory I've put on my option window at the very beginning of the Siemens demonstration part 1. And here I can change the name of my vector layer. So I'm going to select October and 10 for the downsampling. Here you can click on Vectorize to compute the vector field. If you close this window and hide the V0 and U0 scalar layers, you can see that the vector field of oceanic currents is displayed, and it's clearly visible along the South American coast. Here you have still access to the properties of these vectors. So if you go here to your layer of the vector field, you can still go to Properties, Symbol, and change. For example, if you want to reduce the size of the symbol, change the size, click on OK, Apply, and OK. and the symbols are smaller. So you have several options of downsampling. If you go back to vectorize, you can change between 2 and 100 to select the downsampling which is the best to the representation of your vector field. So that was a presentation of two advanced functionalities of this NetCDF plugin using Copernicus Marine Service data. All the information on how to use this plugin are gathered on the user manual that you can download with the plugin following the link on this video. Thank you for your attention, and goodbye.